Hi guys, welcome to the video. As you can see from the thumbnail, this video is all about generating 4-axis G-code for the foam cutter. Now, as you might be aware, there isn't a great deal of it around, and when I first started, there was only two, one free and one paid. So it was a little bit challenging back then. But luckily now there's a few around now. The free ones and the paid ones have just got even better. So in this video, what we're going to do is going to have a look at the G-code, and there's 4 free ones and 2 paid ones. And so the ones we're going to have a look at is Wing Gcode, which is the first one I ever started with, and it's been developed quite a bit more as well. So it's and I've done a little bit of development on it myself as well. So that's getting better. Then we've got Wing Wire. That's a really good one as well. Then we've got Wing Designer, and then we've got the infamous Jedicut. And for the paid ones, we've got DevWing Foam and DevFus Foam for doing fuselages. And then what we've also got as well, which is free from DevCad, is their simulator, DevSim Foam. So that's really useful for running your G-code through to make sure it's going to run okay. And the times I've set jobs going, in the early days, and then you get halfway through and you think, God, I didn't want it to do that. Why has it done that? And now you can check it all. And now I do that. It saves a lot of mistakes. We'll also run it through the controller program just to make sure that there's no G-codes that it's not happy with. Had that just over this weekend. Had a guy had some problems, sent me the G-code, and it turned out to be some spurious code that was getting into the GRBL controller, and it was throwing an error. What it was doing was just pausing. What we'll do, we'll have a look at each one, and if you are thinking about building a foam cutter, one of the things I suggest you do is have a look at the software first, because I've had a few guys that have contacted me. They've built fantastic machines, and then when they come to generate the G-code, they get a little bit disappointed. It's usually because they've got a CAD file, like a DXF file, and they're trying to load it in some software, and there's only ones really that will load them in, and it's sometimes it will and sometimes it won't, and then they get a little bit disappointed then. So do check on the software first before you think you're going to build a machine. Any guys that contact me now over email, or I generally say to them, have a look at the software first before you embark on building the machine, because if you build a machine and can't get it to do what you want, it's a bit disappointing really. So at the end of the video, what I'll do is I'll summarise them all, give my thoughts on them, and so you can make a decision about what's going to be best for you really. Just a spoiler alert guys, the paid software is the best in my opinion. So we'll go off and have a look at the first one, Wing Gcode. So the first one we're going to have a look at is called Wing Gcode. Now this was the first one I ever used when I started foam cutting, probably getting on for 10 years ago now. And it's been online for some time, and it's been developed by, I think it originally started as a 3-axis, and then a guy called, he goes by the name of David and he's quite active on the Open Builds forums. And he also took over the development of the SketchUcam plugin, which you might have heard of, which was a plugin for SketchUp that allows you to use it to create CNC parts with a CNC router. And it was the first one I ever tried on my CNC router, and it worked really good. But David also developed this one as well. So it's been online for quite some time. So I'll just switch over. Yeah, so it's been online for quite some time. And on the website, I've got a post in there with all the details of all the different ones we're looking at. Just before we have a look at it, nearly all these softwares that we're going to be using uses something called DAT files. And all DAT files are, they're just coordinates. And if I open one up and show you, so if we look at this, and you can see all it is, it's just a load of numbers from 0 to 1 and down to -1 as well. So if you look at all this settings there, and the image we've got there, you can see that there. So we've got 0 there, and we've got this one goes down, doesn't go down very much, and doesn't go very, but it goes from 0 to 1, and it's all the coordinates. So all this software that we're looking at uses these DAT files. One or two of them can use different formats, but we'll get onto them, as we cover them. So the software we're going to look at, a lot of them have the DAT files installed, or have a few installed. But if you need any more, then there's a link here on the website, and I'll put it in the description of the video as well. And this is probably the most popular one. So this is the URUC Applied Aerodynamics group, and in here there's just about every airfoil you can ever think of. So what I would suggest, guys, is you try and use a DAT file. I've had some guys that they've used Fusion 360, and there's a few tools you can use to import DAT files, and then they export it as a DXF, and then try and get it into one of these programs, and it's just, it just doesn't work very well that way. So you're better off starting with a DAT file. So there's a few popular ones for model making, as you're probably aware. There's the Clark Y, there's the MH series for flying wings, and then the ones we were just on there, the HQ series. These are quite popular for sailplanes as well. So if you're looking for a particular aerofoil, this is probably the place to come. And you can, if you come here, you can get there's a GIF image there of what it looks like, so you can get like an idea what it looks like. And then say you wanted I don't know, say this HQ258, so let's just have a, well, that doesn't match, obviously 258, and it's got 2512 there. We'll look at the 2512. So say we wanted this aerofoil. So all we do is we just go onto it there, right click, and then save link as. And then I've got a load of aerofoils in this coord database, which you'll see in the Wing Gcode program. So what we'll do, we'll just save it in there, and when we come to fire the program up, that'll be there for us. So have a good look here. There's also some good links on there as well to some other resources. Yeah, so it's worth a look round here as well. There's some interesting stuff if you like building your own aeroplanes. So if we just go back to this first one we're going to look at is Wing Gcode, and as I said, it was by David de Sorfa, and this has been online for some years, and it was the first one I ever used. And if we just open it up online, it's running a little bit slow at the moment because I've got the screen recording software. There we go. And basically all you had to do was create yourself a registration and log in, and then you could go through and put all your details in, and it would generate the G-code for you. I've actually done this in one of my other videos, so I'll put a link up if you want to have a look at how that works. Now the only issue with this is that it generates the axis letters X, Y, U and V, which doesn't work with our GRBL foam cutter. But sometime after this, David actually developed a Python version. So if you're familiar with Python, it's a scripting language, and it's really popular. You can do all sorts with it. I'm quite interested in it myself as well. So David did a version that was written in Python 2. Now Python 2, if we just go onto Python website, what happens now, if you're looking for the, I don't know what it says, I think somewhere on here it will tell you that Python 2 is not being supported anymore. So you're better off using Python 3. Now, there isn't a great deal of difference between the way they work, but there is some. So what I did while we were in this lockdown period and I was sort of sat twiddling my thumbs a little bit, I thought I'll take a look at it, see if I can convert it to Python 3. And I've managed to do that. And also what I've managed to do as well, if we go on to the website, as well as the Python 3 script, which you need to download Python and run, I've also managed to create an executable as well for Windows. So if you don't want to download and run Python, you can just download that, run it up, and it's exactly the same. I've got both versions on this laptop, so you'll see them both. So just download whichever one you prefer. The beauty of the Python script is that you can run that on Mac, Linux, even Windows if you've got Python installed. I've got Python installed on this as well, as you might have guessed. And but if you don't want to get involved in doing that, all you need to do is just download the Windows 64-bit executable. I haven't got a 32-bit machine, so I can't create a 32-bit executable. So if you've got a 32-bit machine, then you'll probably have to use the Python 3 script, and it's quite easy to install. You know, there's loads of videos on Google about installing Python 3 on Windows machines. So once you've got it downloaded, now this doesn't need any installing. You just download it. I've already downloaded it, and if we just go to my downloads directory, and this is it. This is it here. This Windows executable, Windows 64-bit. And these are the files in it. And all you have to do is extract it to wherever you want. I've already extracted it. So I've extracted it to, there we are, Wing Gcode. And all you have to do is run it. You can actually see there's Python actually embedded in there. So although you don't need Python, it's already built into it. And all you have to do is just run the win.exe program. Now the two folders on there, the top one, coord, that's where all the DAT files go in for your airfoils. And then the Gcode directory, that's where all your Gcodes that you've created get saved into. Now within the program you can change that if you want to. So what we'll do, we'll just load it up. I've actually created a desktop shortcut on there. I'm not going to do that. You probably know how to do that yourself anyway. So I'll just create a shortcut for it. And there it is. Now just to prove that the it's no different to the. So we just go into this file location. So this is where the actual one that runs under the Python interpreter. So if I just double click on that, just get it out of the way, pull it across, you can see they're absolutely identical. And so one's just a bit easier to install if you're on Windows and you don't want to be bothered installing Python, and the other one will run on any machine. It actually looks quite nice on a Mac as well. I've tried it on my Mac and it does look really good. So we'll just close that one down for the time being and we'll go back to this one. Now I am doing a little bit of extra development on this software. As you can see at the moment, we've got the different access letters there. So we've got X, Y, U and Z, and then we've got down the bottom generate Gcode. I'm working on it and I've got it working, but I need to do some more testing. I'm working on what's called a G93 mode, and that's to do with feed rates, and it works really well on foam cutters. It originally comes from rotary accesses on CNC machines, but it works really well on foam cutters, especially if you've got a root and a tip where there's a big difference in the size, or you've got a swept back ring. I had some experiences when I was using Linux CNC without using G93, one of the axes would go like crazy trying to keep up with the other one, and it was all to do with this feed mode. So yeah, and I managed to get it sorted. There was a very clever guy on the Linux CNC forums that came back to me with a Python script to load in the Linux CNC, and it worked brilliantly. And the G93 that I'm putting into this is mostly based off of that as well. So what we've got on here, we've got, if we have a look at edit there, so this is where you can change your directory. So if you go Gcode directory, so that's where it is at the moment. If you just want a different directory, just select the one you want there. And then the that files directory. So it just picks up the last one for some reason there. So let's go up. So it's that core directory there. Select folder. And for them to take effect, you need to stop and restart the program. And then we've got model there. So when we've done our model, let's see what it's done when I've been playing with this. It's loaded the last one I've done as test wing. So you can load your last model in. So we do load, and it finds it test wing. And it's just an ini file with all the settings that are in here. So it says it's loaded it. And then if you change your settings, you just go back in and save it, and it's got all your settings saved. So just give it any name you want there. On the wingspan, that's the half wingspan. And on the washout, I'll put a little picture of washout on there, but you probably know that's used for wings that are swept back quite a bit, and it's to stop them tip stalling. So we've got a setting for washout. The root chord, so that's your root chord. And all these figures in here at the moment are in millimetres, but if you want to work in inches, just switch over to inches there. And this is the half span. So if you've got if you're building a 2 metre glider, then that wants to be, 1 metre or 1,000 millimetres. You need quite a big machine for that anyway. So we've got root chord, tip chord, and that airfoil we downloaded earlier, that HQ, it was that one there, wasn't it? HQ 215. We select that for the root, and then you can select the tip profile. They don't have to be the same, but for this demo we'll keep it the same. Now the foam chord, that is the size of your foam, so that needs to be bigger than what your root chord is. Sometimes it needs to be quite a bit bigger. If you've got a swept back wing, you need to have a fair bit of foam to account for it. Foam thickness, so that's the thickness of your foam. So I've just got 100 millimetres in here. Trailing edge limit, what that's to do with is if you're, when it comes towards the trailing edge, the hot wire, as it gets down towards the bottom, so on the trailing edge, what happens as it gets down towards the bottom, it can get very thin. And on this program here, you can tell it, I don't want you to go right to nothing. I just keep a certain amount in there, probably. So in here, we've got 3 millimetres. So what you'll find sometimes, if you don't do that, it'll just burn away. So that's a real good option. Then we've got the sweep of the wing. So however far swept the wing is. The carriage length, that's the distance between your carriages. And then we've got feed rate. So the feed rate, I use 120 or 2 millimetres per second. So this feed rate is per minute. So that's 120 millimetres per minute. So if you were going to inches, you would just put the appropriate setting for inches in there. Then all you need to do then is select your what axis letters you're using. So we've defaulted to the GRBL. X, Y, U and V, that's Linux CNC. These two here are for what David says on his GitHub website. They're for machines using a bow. I'm not quite sure how that works really. I might drop in an email and ask him about that. So all we need to do then is once we've done that. Oh, there we are. What we got there? No, I think it's something about them AirFoils it doesn't like. Let's try a different AirFoil. Let's try a 45. sometimes what you find with this, you have to play about with things to get them how you want. So it's, yeah, there was something about them AirFoils it doesn't like. So what you see now is it's actually generated the Gcode. It hasn't written anything to files yet. So, and as you can see, we've got XY carriage on the left, which is what we've got there, which is what we have for the GRBL foam cutter. And then once we've done that, what we do then is we then say write to files. And then we got the Gcode created. So if we go into the folder where the Gcode is, this PC, Gcode. There we go. And one of the things when Gcode does, if your foam's thick enough, it will actually create both AirFoils, so you can do them in one cut, which is, and what it does, it does one upside down, so they're quite close together. So it's a real good option. That you'll see that when we look at the simulator. Right. So we just have a look at the Gcode. It's because I've done this before. So you can see that there's all our Gcode, and we've got comments in the top there. This here in brackets is to do with Linux CNC, so it doesn't have any effect on what we're doing. Now once you've generated that Gcode, what you want to do is double check it to make sure it's going to be okay. And the best way to do that is with an application that's free from DevCad, who do the DevWing Foam software. So if we go on to DevCad, and if we go to downloads, right down near the bottom, we've got this DevSim CNC Foam, and this is a free application, and it will read in many formats of Gcode, and it will show you what's actually going to happen, which is a good thing to do, because a few times I've not done that. I've put my foam in and then it's got halfway through and done something. I thought, oh, I didn't expect it to do that, and it's ruined foam. So all we need to do is download that from DevCad, just install it like you would any other Windows application. I've already got it installed. So what we'll do then is we'll go DevSim CNC Foam, and here it is here. And there's a few settings you can change. So you can put the size of your machine in, the size of your foam block. Hot wire band efficient doesn't matter for this because it's just for simulation purposes. And see, there's our speeds in there. And all we do then, these grey boxes here, this is the size of our machine. So this is the travel we've got in the Y, and then the X. What I tend to do is take them off because you can see the actual cut a bit better. So what we'll do now is we'll load that Gcode in, test swing both, and there we go. So you can see the actual profiles on there. And then what we do then, we set it going. Now it's running quite slowly at the moment, so what we can do, we can speed it up. And you can see that trailing edge limit there. And there we are. It looks like we haven't got any problems there. So this is a real good program to check to make sure your Gcode is okay first, because what you don't want to do is put your Gcode in, find you've got some setting wrong, and you go and drive the axis into the stops and cause some damage. So that's what we're going to do is check it like that. So I've got my test Arduino here, which I can just plug in, and it will just like simulate being connected to the foam cutter. Plugged in. Let's see if we can get plugged in. There we are. So we're plugged in there. Right. So what I'll do, I'll just switch you back to the screen. So what we can do now is we can run up the GRBL software. And this is the latest version. I've done a few changes on it. So if you go to Help, About, you should see version 4.01. And then you can have a look at the changes there. And the main things really are, it now responds to the GRBL error codes rather than just putting up a message like unhandled exception, which you might have seen once or twice. It puts up a proper message from GRBL. It's the standard GRBL error messages, so it should give you an indication of what's gone wrong if something has gone wrong. So that you can have a look at the changes there, and I think this version is probably the best version so far, and I've been testing it quite a bit and it seems to work fine. So what we can do with our Gcode, if we connect and then load our file in, test swing both. So we've got both profiles in there, and then we've tested it in the simulator works. Okay, what we need to do is make sure that GRBL's happy with it as well. So if we press check, and what it will do is it'll run through the code without actually running the access. So it'll just run it through the machine. So we come down to run, and it will just run through it there. And if there's any problems, you'll get a message. So, and quite often it will be one of the standard GRBL error messages. This newer version will also the GRBL foam cutter doesn't support every single Gcode command because it's such a tiny machine. It hasn't got the memory and processing power to do that. So there are some Gcodes that are not supported. So in this newer version, what it does, it will, if there are any of those unsupported codes in there, it will just ignore them, and so you shouldn't get any errors. So so if you've done the simulation and you've run it through here, the chances are it's going to run okay. So here we go with the test cut on Wing Gcode. So we run it through the simulator, we've run it through the GRBL check. So now it comes to actually putting the machine into action and see if it does what we expect it to do. And as you can see here, it's going. I've got the wire a little bit too hot here. I was doing some testing with something else and I was messing about with the settings. Now this is running about 16 times speed. That'd be nice if it did run that quick. But yeah, you see it's done a real good job. And what we'll do, we'll just take it out and have a look at it. And there it is. And as you can see, I had the wire a bit hot. It's burnt through a little bit at the back. And then we've got that extra bit of trailing edge on the end. So that's Wing Gcode. We'll just go through what it doesn't rather than going through everything. DXF import, no, it doesn't support that. There's only one program here that really supports that in Div, and that's hit and miss. So DXF import, there isn't really any software that works very well with that at the moment. Wing plan from image. Now that's something that DevWing Foam supports. So if you're doing a scale wing, you can then, if it's like a sort of really curved wing as that, you can then bring that in, and DevWing Foam will allow you to create that wing plan from that. Curve settings, and that's the amount of foam that's melted away as the wire goes through. Now we haven't got a setting for that in Wing Gcode, but it's not a big deal anyway, because if you know what your curve setting is, and if you have a look at my last video, I did a little demonstration there how to work out your curve setting. All you need to do is say if you've got a 250mm root cord, just add a millimetre onto it, if that's your curve setting, and that should get you, pretty close. So we've got washout. There isn't an option for dihedral, but that's not too bad to do, because you can, if you've done any wing building, you'll know you can just set the tip at an angle and then join your wings at them angles. Spars, There's no option for spars, but to be honest, most of the time now I don't use spar options, even in the DevWing Foam firmware. I tend to use my Dremel with a tile attachment on, and I'll put a bit of video in to show you that working. And then ailerons, no, we can't do ailerons with it, but to be honest, foam ailerons, unless you're doing a really big wing, they're not very strong anyway, and you're having to reinforce them, so I tend to use balsa for the ailerons anyway. Trailing edge thickness, yeah. Lightning holes, no. Rotate the plan form. That isn't available at the moment, but I'm working on making a little utility to do that. What that's for really is if you've designed a wing but you haven't got the travel on your foam cutter to actually cut it out, what you can do, you can rotate the wing so it lines the wire with the trailing edge, and then you cut the wing out that way, but then you have to trim the root and tip. And I do that all the time because it saves a lot of foam as well. But so that might be coming in a future update for this. G93, I'm working on it at the moment, and that's probably going to come in. We haven't got a simulation on it, but we can use the DevSim CNC Foam. Yes, it's free, and it will work on any of the operating systems. So if you're just starting out, guys, on this, I'd highly recommend you try Wing Gcode. So hopefully that's given you a good insight to Wing Gcode, and if you're just starting out, give it a go. And it's a real capable program, and it was the one I've cut my first wing with, so I've got a little bit of a thing for it anyway. So what we'll do now, guys, we'll go on to have a look at the next one. So this next one we're going to have a look at is called Wing Wire, and it was put together by a guy called Dominic Schuler. I'll just switch over to the other screen so we can bring up the web page. And there we go. There, this is it on the website. Wing Wire 4-axis Gcode for it. And I have used this one. I haven't done any test cuts with it yet. But I've run it through all the tests of the simulator and the garble check, and it all checks out fine. Now, the reason Dominic built it is he built his foam cutter, and he's done it all 3D printed. So if we just go onto the Thingiverse and have a look, and this is actually where you get the code from as well. So there's his machine there, which looks really good, and we've got some pictures there of it showing, and he's using a bow rather than a wireless tension. But he built it, and as he said at the time, there isn't a lot of free software around, and I think when you're first starting out with this, if you've not done a lot of it before, you're probably a little bit reluctant to shell out the paid software, because you might find that you have a go at it, you think, oh, this isn't for me really. Go on to Thingiverse there and have a look at where it's got thing files. If you scroll down at the bottom there, the actual code is there. It's called Wing Wire, and I think he's actually got a link to a video as well, which you can have a look at as well. Somewhere on the main page, I think. Yeah, there's a video there on YouTube as well. So this works absolutely fine on the software on the website. So now the only thing with it uses Java. So when you've downloaded it, I've got it downloaded already, so I'll not download it again. We'll just go into my downloads directory, WingWire. Yeah, it comes as a zip file, and then when you extract it, and you can see I've already used it before. We just get rid of that setting so it's like a brand new install. Delete. I'll delete that as well. Now, it uses Java, so what you'll need is, if you haven't got it on your computer already, you'll need the Java runtime. So if you just do a search for Java runtime and just go on to, so if you haven't got it, just download it from here and install it as you would like any other application. And that's all you need really. You don't need to do any configuration or anything. So once you've got that, all you need to do then, go back to and then just double click on this wing wire jar file. I think it stands for Java Archive, I think. Could be wrong on that. And then what we get then is, it then starts up. And one thing Dominic's done, which is really good, if you look at the corner, there's a little eye there for information. And he's got quite a lot of information on the different pages, which is really good. I know a few guys have actually been using this software. Some guys have come and said they use it and they've been quite pleased with it. So probably the first thing to do is go into settings and just check everything's set correctly for your machine. So we've got X, Y, U and Z, Y length. My Y is a bit longer than that. Horizontal axis, probably 330. So that's your settings saved. And then all you need to do, again, this uses AirFoils like everything else. So we just go and select our root airfoil, wing Gcode, wherever we airfoils in there. So we'll just load up a Clark wire just for demonstration purposes. So select the root airfoil, select the tip, chords, and we'll select the Clark wire again. And these figures down here, cutting points and distribution coefficient, if you look in the information there, Dominic says that they found these values to work well, so I think he's saying you do not recommend changing these, so we'll not do that. So then we go on to the wing config, and then this is where we can put the details of our wing, so wingspan. So if that's a bit small, so let's do a 500 wingspan. We'll just put a little bit of sweep on it. The root, call that 250, and we'll do the same on there. And then the foam thickness, let's assume I've got a big piece of foam again. Hinge line percentage. Now I think what this is, if we have I don't know what it actually tells you on this information. So if you look at this information page, it explains the settings, which is really good. I think on the next page it shows you. But I think the hinge line percentage is, if you're going to do any washout, it's whereabouts it takes the actual pivot point from. So we'll just leave that as a minute. Alpha root, alpha tip. I think this is to do with washout. So if we just put 3 in there, does it? I'm not sure if it updates fully. Block length. So we've got our block length. So we're doing a 500. So we want 250. Yeah. So we want probably about. Let's go 400 there. The X block shift, let's have a look at that. So that's from the start. Oh, what happened there? There we go. X block shift, so we'll leave it as if for the time being. Center line. Yeah. So as you can see now, this is come under here. So let's try that at, we're still in there. Yeah, let's try that at 50. Yeah, that looks better. Base thickness, so if I look at so that, I think that's your base thickness there. So that's the distance from the centre line up to the base of the airfoil. So we see we need a bit more there, don't we? It's quite close. So let's put 15 in there. Yeah. maybe a little bit more, still looks a little bit close at the back. And you can see we're actually doing 2 airfoils here. You can do 1, but it says it's beta, so probably as well to do 2. So there, that's looking quite good. And I think you can see we've probably got a little bit of twist on there. X shift. So the X shift. So this is the wing, I think. So this is the X shift on the wing. So that's how far it is from the. So we've got 50. So yeah, that's okay. In fact, I think what I'm going to do, I think I'm going to move the base and Z shift, and that's it. This is the Z, how far it is across the. So I think Z shift, yeah, it's that distance there. So we move that across a bit more. Let's go 100. Maybe 125. Oh. Yeah, so you can see there, I said my wire length is 770, so you can see there, and there's a 0 there. So we've got the block somewhere near the middle, and we've got a little bit of sweep on it as well. So that looks okay. So we go to cut path on the next one. We can see what it's actually going to do there. And I think this is where this hinline percentage comes in. Yeah, so that it's where it's actually pivoting the wing from. And then what we've also got on here is the kerf as well. So we can put kerf settings in, which is really good. So if you have worked out your kerf settings, you can put them in. And so we've got options to trim the edges. So I usually run at 120 there. And then we can trim the edges. I'll leave that because I haven't tried that option yet really. And then what we do then, we go into Gcode. Now, if there's any problems, it will pop up with an error here. X value exceeds axis limit. Right. Wire length, horizontal. No, I've got the wrong one in there. That should be 550. That's why it came up with that error. So we'll put that in. If we go back to Gcode, yeah, there we go, we're okay now. Now guys, if you do use this, do consider giving Dominic a donation, because he's put a lot of work into this and it looks a really good program. And I've run some simulations on it, it all seems to work fine. So what we do now is we do an export, and yeah, we'll leave it in there, just so easy to find. Anyone can give it a name. We'll just call it wing wire test. There we go. So we've got wing wire test there. So here's our Gcode. So he's got a feed on every line, but you probably don't actually need that on every line. Thing with CNC, what it does, if you don't put a feed on the next line, it keeps using the previous feed until it changes. So we'll bring up DevSim. And we'll take them off, and then we'll load it in and have a look at it. Go into downloads, wing wire, and it's a text file, so wing wire test, open, and there we are, we've got both. Yeah, and you can see we're doing 2 wings. All these different programs have got their own ways of cutting. So if we watch the simulation on this one, you see it goes over the back, comes and does the top one. Speed up a little bit. Have a cup of tea. and you can see that that works absolutely fine. So that's another real good one to use. I haven't done any real cuts with it yet, but I've run it through the simulator, and if we plug in the controller, so I've got the controller here. Like I said in one of the previous tests, it's just thinks it's connected to the foam cutter, but it's good to test that the actual garble is happy with the Gcode. So that's down there. So if we now still got the last one there. So if we do a connect, do a rescan because I've had it disconnected. Connect, and then we'll load a file in. Go to downloads, wing wire, and there we go. We've got our 2 in there. So we can run. So if we put it on check, and now if we run. Do the start resume, we should run through it then and see if there's any issues. And that's it, it's run absolutely fine, guys. So you know that's a real good one. So you know, if you're looking for a free option, and in my opinion, it's much better than using Jedicut. If you're just doing wings, then with DAT files, then you know this wing wire is a real good one. I know quite a few guys are using it, and they're very happy with it. So Dominic's done a real good job on this. And if you do use it, guys, you know, do consider a donation. You know, because he's obviously put a lot of work into this, and I think donating as well, it might encourage him to continue developing it as well. So if we have a look at the comparison chart, so we've got wing wire, DAT files, yes, DXF input, no, wing plan from image, no, curve settings, yes, washout, yes, dihedral, no. Spars we haven't got, ailerons we haven't. I think I have put ailerons there. No, that should be a no there. I need to update that. Trailing edge thickness, I think there is a way you can do that, but I need to investigate that a little bit more. Lightning holes, no. Rotate the plan form, no. G93, no. Cutting simulation, no, but we use CNC Foam for that, so that's good. Free, yeah, and because it's Java, it will run on any system. So you can run it on Macs, you can run it on a Mac, Linux, and Windows. So that's a real good one, guys. So you know, what I suggest you do is give all these a try anyway, see what suits you best. So it has got a few more options, and you know, and from the guys that have contacted me, they seem to be really happy with it. So what we'll do now, guys, is we'll go on to have a look at the next one, and this next one has really impressed me as well. So let's we'll see you in the next one. So this next one I'm going to have a look at, guys, is called Wing Designer, and it's all online, and I've been really impressed with this one. You know, it's quite amazing what the guy's done that's developed it. So we'll just switch over. Now the guy that's developed it, and I hope I've got this pronunciation correct. I put it into Google pronunciations to see if I'm doing it right, and I think it's George Milovic or Jolovic or something. Yeah, if I've made a mess of that, I'm sorry, but that's the best I can do with my limited pronunciations. So it's Wing Designer for 4-axis CNC Foam Cutter, and it's really impressive. So we've got the link down there. Now, I have spoken to George, we exchanged some messages, and one of my concerns was that with it being online, would it always be there? Because you probably know yourself, guys, sites come and go. and but he's assured me that at the moment the hosting isn't any problem for him, and he says if it ever was a problem, he would put the code up onto GitHub, so we could have access to it there, which is really good of him. So yeah, and I think when you see this, you might have seen this already. I think you'll be quite impressed with it. I certainly am. So we'll jump onto the website there, and it takes you straight in there, and everything's down at the side here. And if you've got stuff you've done before, you can open and save it. So what we'll do, we'll just go through it quite quickly and just show you. So we'll do select AirFoil. We'll select a different one this time. We're picking it up from the same directory as the Wing Gcode. It just goes to show they all use the same format of DAT files. So we'll do an MH60 this time. And then let's put 250 in. And then for wingtip, we can leave it the same. Or if we don't want it the same, then we can select the airfoil. So we've got the same airfoil selected, but now we can alter the route. So if we do, so we can alter the tip. So let's just do 190 there. And you can see down here, it's changed it down here. And then we've got tip profile thing, so we can actually change the profile. We can do that on the route as well. You know, if you have a watch of that, you can see it's going way up there. So that's really impressive. And this is where we do our washout. So you can see there, we can either put so on the washout, we would tip the wing up at the back there. Now it looks like it's rotating from the nose, where some of these you've got the option of where the rotation takes, where the rotation comes from. So I think as it's coming from the nose, I probably wouldn't give it more than, say, a couple of degrees or even 1 degree. Yeah, go 1.5. So that's giving us that washout on the wing. So what we do then, we go into dihedral and sweep. So the sweep, so we'll just put a little bit in, we won't put a lot in. Let's put 25 in. And we should see that move on there, you can see that move. And then we've got dihedral. Now what you'll see with the dihedral, you'll see the tip go up depending which way we want to go. Because you go the other way, I think it's called anhedral. So let's do, so this is done in millimeters. So let's do, so if you want to work in degrees, you'd have to do a little bit of maths and work out what that would be. So let's do, can we do 5? See what that does. Yeah, so that's moved it up a little bit. And on the preview, you can rotate it. So yeah, probably better on a much bigger screen, because I'm just running this off a laptop screen at the moment. It'd probably go a lot better off a bigger screen. So then what we can do then, we can go into wing segments. So if you were doing a multi-segment wing, you could do it here, but I think we'll just leave it as one segment at the moment. And we can do spars. So if we add a spar, and it's got some default settings. So 5, let's just make it a bit smaller. I tend to do mine a little bit smaller on flying wings. There we go, that's a bit smaller. And this is where you can alter where you want the spar in relation to the. Generally, you tend to find that the spar is like the thickest point of the cord of the wing. And this is the bit that really impresses me as well. You can alter the end. So if you didn't want the hot wire to come in from the top, wanted to do it from the bottom, just swing it around. Somewhere around about there. And then if we just alter That looks about the, yeah. And then we can decide whether we want to be as a separate pass or cut during the airfoil. I tend to leave it as that. So that's really impressive as well. So then we've got ailerons as well. So we can add an aileron. And you see it's put it in there for us. What's really good is we can alter the thickness there. So if we scroll into that at all? No, don't. But if you watch over here, what happens is, if we alter the thickness. Oh, sorry, that's the position. Yeah, so we can change the position where we want it to be. And then we can also change the hinge material thickness. So if you watch here, we can alter that. So if you wanted to make a hinge with foam, you could just get it to leave a little bit there, and that would become your hinge. And then we can choose the angle of cut. So if you wanted a really steep angle and that, so you've got a lot of configuration there. Very impressive. And then the machine setup, we've got our axis letters there, and then we've got, and what's good as well, we've even got a preview here of the block in the machine. So we've got our axis. That's not quite right for mine. Let's just change that to 330. That's it. Hot wire length, cutting speed. Yeah, so that looks all right. Foam block. Now we can tell it where we want the foam block. So if we have a look at that, looks like the foam block's a little bit to one side. So let's go 125. See what we get there. Oh, wrong one. Foam block height. Foam block offset, that was it. 125. There we go. That looks reasonably central there. So you can see where your foam block's going to go in and the position and everything. So, and then we've got our profiles on the side of the block there. And then we've got Gcode options. So we can generate the comments. We can use home if we want to, but I don't tend to do that anyway. And then we've got, it's actually got its own simulation in as well. So we go to Sim and Gcode. Now, if there's a problem with anything, you'll get an error come up here. If it, for any reason, some of the settings are not right. If you've not got enough travel, or your foam block's not wide enough or tall enough, you'll get a message come up here. So if we do a simulate, you can see this is working really well. Now I've actually done a live cut with this, so I've dropped the video in at the end of this little section so you can see it actually working. And the only thing was I did have the wire a little bit too hot, so it didn't come out as best. I was doing some of my testing on different things for people. I'd changed some settings on the controller and I'd forgot to set them back, so the wire was running a little bit too hot. Right, so, and all we do then is so the copy there, so that will just copy the Gcode, or if you want to save the Gcode like that, or you can do export. And if you do export for a selected segment, and then we'll save it in, we'll just put it back into downloads, I think. Just put it into here. And this is an NGC file. You see, I've already done this, so we've exported the Gcode. The other thing you can do, you can save as well. So if you do save your settings, and this is a JSON file, and then you can just put whatever you want in there as a name. So call it MH60 test. And then if we open up DevSim and go to downloads, there we are, yeah, left wing segment. If we open it up, there we go. So this one's doing it from the front. I'll just take them off there. If we scroll in a bit, and then if we run through it, that was a little bit quick probably. Let's go to the back again. And you can see it's doing a real good job there. So that looks absolutely fine. And just as a double check, then we'll run it through the foam cutter. We'll open the file up, downloads, left wing segment, open, and then we've got check on there. And then when it brings these files in, it's trying to fit as much as it can into the preview. So the preview isn't always a good representation of what it's actually going to be like. So if we now we run through a check now, and that's checked out okay. So there shouldn't be any problem running that either. And I have run this on the machine, as I've said earlier. So I'll put a little bit of video up showing it cutting. Look at all the option. I'll put DIY RC Wings, which is the website really, so it should really be Wing Designer. So I will change that. So DAT files, yes. DXF import, no. Wing plan from image, no. Curve settings. Again, this hasn't got curve settings, but again, like Wing Gcode, you can just add your curve setting onto the actual root and tip. So we've got washout, dihedral, spars, aileron. Trailing edge thickness, no, it hasn't got that, but you can probably work around that anyway. Lightning holes, no. Rotate the planform, no. G93, no. Cutting simulation, yes. Free, and it will work on any operating system. And so I've been really impressed with that one, guys. And if you have a look at the wing, the actual cut I did with it, it worked absolutely fine. So I highly recommend you give that one a try. It's well worth it. And thanks to George for doing that. Hopefully I pronounced your name right. So what we'll do now is we'll go on to have a look at the big daddy of them all, DevWing Foam. So we'll have a look at Wing Designer doing a cut. So I've got it set up here on the foam cutter, and I've just got the block held down with a bit of double-sided tape, and I'm running it here on this time lapse. It's about 16 times speed, because otherwise you'll be sat here twiddling your thumbs. So we're coming down to the back end, and then we're going up to do the aileron. And again, I've had the wire too hot on this. As I said previously, I was doing some testing on 12 volts and forgot to change the setting back for 24 volts, so it made the wire a bit hot. So we'll just have a look at it, see what it looks like. And as you can see, apart from having the wire too hot, that's pretty impressive. So this is a real good one, guys. Have a look at it and let me know what you think. So this next one we're going to have a look at is the infamous Jedicut. It's the piece of software that I get the most questions about, and I think the reason for that is it's not the easiest thing to use. I think the main reason that people get attracted to it is because it has a DXF import, which sometimes works, sometimes doesn't. I've had quite a few guys contact me saying they can't get the file to import. Do I know what's wrong? To be quite honest, guys, a lot of times I don't. Sometimes you can save it in a different version and try and load it back in, and that sometimes works, but it's a bit hit and miss how it works with DXF files. So what we'll do, we'll just switch screens and we'll go and have a. So I've already got it loaded on that, and I've done a video on Jedicut before, so I'll link you to that to show you how to use it. So I'm not going to go into too much detail on it, so I'll just link you to that video. But it is an option. It's an option I wouldn't advise you go for unless you really need this DXF option. I think this is the latest version. Yeah, 242. So basically what you do is you start off with a new wing cut profile. There's where you can create your own profile. So I've never used it that way. So all you do is new wing cut, and then you're asked then of what profiles you want to use. So if we can click on there, I'm going. So it's looking for a Jedicut profile file, but if we just change it, and this is where we've got this option for. Well, you can't see that, can you? Let me just move that across. That's better. Get my head out of the way. Yeah. So there you've got that DXF option there, and a few other options. I have got it to get some DXF files in and others not. So, you know, what works and what doesn't work, I've no idea really. It's just pot luck if it works. But if we look at the DAT files, let's just go for a good old Clark Y. So there's a Clark Y. Let's make it a bit bigger so you can see it. Yeah. And then you can, if you say symmetrical airfoil, it does that. Then you can take that off again, and then you can go and you can change all the sizes of things in there. So you can put a twist angle in. So if we just view twist, so that's your washout. So if you put 3 on there, it moves it up 3 degrees. And then you can put your tip chord. So let's do a 250 and a 250. And if you do cut wizard there, you have to put it on, because if you go into the cut wizard on the next one, you can't change anything. Skin thickness is where we can use that for the curve value. So we go into cutting wizard there. So what we've got there is if we press the button there, it centers the cut for us, and then we can put in the scale. It calls it scale. I think on my other laptop I've gone through some of the language options and changed that to wingspan and a few other things on it. So that's on that page there. As I said, I'm not going to go into too much detail on this. You can go into the ribs manager and create spars. So if we just put a spar in, and then and this is the one that causes most confusion, this cycle of cut manager. And as you can see, these are still in French, and even though with Google Translate you can sort of work out what it is, but then it shows you how it's going to do the cut. And if we just, I think that means default cut, I think. And then go up to the top there, vertical. And you can step down through these and see what it's going to do. So if you notice at the top there, this is coming down, so it's doing vertical. Then that, I think that means top profile. And you see it, for some reason it goes down the bottom, it goes up the top. Yeah, so you know, it's just a bit weird, to be honest. I heard one guy on, I can't remember, it was on one of my videos, on a comment on the website. He says Jedicut's a wild ride, and I think he's got it absolutely right. So if we say OK to that, then what we can do then, we can go into the cut preview.
cut through. Yeah, there we go. And you can see that gives us, just make that wider so it covers it all. And then I think this is this start height that we put start height at, let's put it at 0, see what it goes. Release height 100, see what that does. I don't use Jedicut, guys, as you might see from this. I just find it's not a particularly easy thing to use. So foam height 50, width 50, yeah, it's still doing the same there. So all we do then is we do file, cut, and then we say OK, and that's generated the Gcode. So if we have a look in options, I've got the Gcode option set there, and if you go to preferences, not preferences, sorry, Gcode, that's where it's saving the file. So if we go to there, copy, bring up our, and this is the file that's created for us. So if we bring up the CNC Foam, and you'll notice something quite strange about this. If we put the, paste that path in there again, and that one we just created was that one there, I think. Yeah. And you think, what the hell is that doing? The reason for that is if we go back to the folder, have a look at the Gcode. Look at the Gcode here, all the numbers are very tiny, and the reason for that is because Jedicut works in incremental mode. Now, I've actually, one way you can check it is if you bring up the GRBL software, and if we just open it, you don't actually need to be connected just to have a look at it. Go to that folder again. There we go. That one, I think, on it, yeah. So this will actually display it okay for you. But again, it's as you can probably tell, guys, I'm not a massive fan of it. It's not the easiest thing to use, and it's the one I get most questions about. And I think now if you're just starting out, there's better software to use. The only reason you may want to use this is because of this DXF option. My advice would be to, if you're just starting out, don't use Jedicut. Only use it for if you absolutely need DXF files. So that's a quick overview of Jedicut, guys. If you do want to use it, then be prepared to spend some time trying to understand it. It does work. I have tried it. I have tried some cuts on it some time ago, and it does work. But I personally wouldn't recommend it anymore. I think there's better software around now.
So now we move on to the paid software, and the first one we're going to look at is the one that I use nearly all the time, and it's DevWing Foam 2. Now you may have seen this on some of my videos, and just before we go on, guys, I'm not being sponsored by DevCad at all for this. It's just the software I use because it's, for me, it's the best software to use. Now, you might think the price is a little bit high, but if we go onto the DevCad website, let's just switch it over. Go onto the DevCad website and we go to pricing. DevWing, there we are, DevWing Foam. Now it's €125, which might seem a lot of money, but when you can consider, when €125, that's probably about $150 and about £110 UK. Now it might seem like a lot of money, but when you consider how much you can pay for a really good ARTF model, and you can lose that in a flash, and I've done that, and I'll I'll put a picture up, and maybe I think I've got a little bit of video as well of a McDonnell Douglas Phantom I had, and it's a few years old now, and I think I paid about 150, 160 pounds UK for it, and it flew great until one day I lost orientation with it, and I eventually found it, and all I found was foam confetti, and there was nothing left of it. So it's a bit disappointing when you do that, but and I don't buy models anymore. I get more fun and enjoyment out of researching them and building them. And what you can do, and I know a few guys have spoke to me about it as well, they're actually making wings for their club mates, and that can help recover the cost as well. Now, if you haven't got a license, all you'll get is a little message there that says, and there'll be an option to purchase the license. But if you just select continue, you can still use everything in the program. And as you can see, I've got loads of projects in here. Now, this is one of the benefits of DevWing Foam. Now, I've shown this in my video on DevWing Foam, but say you want to produce a scale model like this, then getting the dimensions can be not the easiest thing to do. But what you can do with DevWing Foam is, if we go into modifier, and you basically start off putting the dimensions in, and I'm not going to go through this in a lot of detail. So what you can do with this, as you can see, you can bring the image in, and then I've already done this already, but what will happen then, you've got the option to go through and generate the outlines, so you can follow the image, and then what happens then, it puts all the sizes into the program onto the next stage, so you can then generate your wing. So you've got all your sizes there. So what you can do then, you can then go and put all your sizes in, and you can move these graphically as well. See, this one here looks to be a little bit out. Let's go on which one are we on there? The first A. So we want to be on A there. And then on the length, that's the length. You can see the length's going across. Then the chord, and we can actually move that graphic. There we go. So that's lined it up there. So there's loads of options in here. So I'm not going to go through every single one of them. And then you can go on and you can create optional splitting points. So if you've got a really big wing, you tell it where you want it to split it. And then we go on to the actual airfoils there. So if we look at so you can get the airfoils. And then when you've got more than one airfoil, using like multiple panels, you can, rather than having to select the other airfoils, you can just tell it to work out what it should be between them. So if we look on the root there, so we've got a Clark Y on the first section. So we've got a Clark Y on the first section, and we've got a Clark Y at the end, but we haven't had to tell it what to put in the middle. And it does interpolate, interpolated, I think. So, but you don't have to have the same airfoils. You can use different airfoils there, and there's lots of settings here. We've got our washout setting. So if we go to our tip, so if we put 3 degrees in there and go up higher panel settings, so that's gone the wrong way there. So some of these software, some use negative numbers, some use positive. So if we use a -3 there, so we wouldn't want that. That would encourage it to stall even quicker. So if we go, so you can see that's gone up now. And what you can do then, there's various other options here. And if you go into the help's pretty good as well, and explains all the options. So if we go into the help, there's all the options are explained in there. Now the only thing I'd say is because there's so many options, it can look a little bit overwhelming. So if you're probably just starting out, probably start off with the simpler free programs first of all, but then as you get further into it, then have a look at this, and I don't think you'll regret it. So we've got quite a few options there. We've got dihedral. So let's just put a little bit of dihedral on the root. So if we put 3 degrees there, and apply it, and you see what's happened, it's moved it up. What we can now do is have a look at the 3D preview. And you see now it's actually, because we've got the wing plan in there, it's laid it over the plan. If we do I think if we do a full wing, it might just join it probably, will it? Yeah, it's just joined it in the middle, which, you know, it doesn't know where the other side is really, so. But what you can see, hopefully, if we put the grid on, we'll just take the image off for the time being. I think you should go around there. You can see the tips up a bit. If I just put the other wing on, we should see that some dihedral there. It's not easy to see on. Yeah, I think you can. Let's have a look at the. Is it that way? Yeah, I think you can just see it there. That the tips. Oh, we're looking at the back there, aren't we? Let's have a look at the. Yeah, I think it is going up slightly, but because of this wing shape, it's difficult to tell. But this view here is really good. So you can take an upper surface off a lower surface, and when you've got all the spars and things like that, and you can see all them as well. So we'll go on and have a look at that. So if we go on to next, and you've got a quick menu here. So if you just want to go to something in particular, you can go to here. That's sheeting. I don't tend to use sheeting. Then we've got leading edge. We can put a leading edge on. We'll just put one on for add a new leading edge. There we are. So we put a leading edge on. Trailing edge. We'll put a trailing edge on just to. And you can go on and adjust all these as well. There's loads of settings for all these. So if we have a look at the you can see we've got a leading edge, we've got a trailing edge. Then we've got spars. We can add spars if we want to. So we can add a generic spar, or we can add one of these that's on here. So we'll put that one in. And then we've got loads of settings. So if we do if we look at the update, there we go. So we've got a spar in there, and there's loads of settings we can alter on there as well. And then we've got ailerons that we can add ailerons as well. So you can either just do them yourself, or so if we put and look at the, probably not going to work very well because we put a trailing edge on as well. So, oh yes we have, yeah, it works. So you can see, and you can adjust all the settings here as well. So you can clearance from the root side, hinge placement, you know. So there's all sorts of settings you can change there. And then we go on to lightning holes. So if you want to put some holes in the blocks, and what you can do is you can just tell it to use a thickness there, apply to all blocks. So you see that's probably getting a little bit thin for a foam wing. So let's change the percentage. Let's put it to 10%. And you see it takes into account all the parts we put in. So it's, you know, what you've got in this program is amazing really. And you know, although you might think, yes, it is a bit of money, but you can see why it is a lot of money because of the features that are in it. You know, it takes people a long time to develop this and test it as well. Because when you think you've got to test for every different scenario, I mean, I know that a bit from the little bit of development I do. So, and then if we go on to next, And then we can go on, this is one I never use here, optional wooden ribs. I've never used that. And this nose checking template, so I've never used that either. So we're saying, and then what we can do then, we can set the Gcode cutting strategy there. DevWing Foam uses G93. Now, G93 is a mode that works really well with foam cutters. It's to do with the way the axes work. I won't go into too much detail about it, but I'm probably going to do a later video on that sometime, because I am looking to add this option into the Wing Gcode program. So yeah, that's one thing to watch out for as well, guys. Just last night I had a guy contact me, says I've been using your software and that, but it keeps pausing, and so I thought, well, that's a bit strange. So I said, can you send me the Gcode? So he sent me the Gcode, and when I looked at it, the Gcode was doing exactly what it was being told. And I think the guy's name Martin, I think. I hope I've got that correct. It's got a slightly different spelling to normal. And he's using DevWing Foam, and what you've got here is stop and pauses. And you've got these two stop and pauses on with this M0, and M0 is a pause. So all that was happening, the Gcode was doing what it was meant to do. But, you know, I think it just flunks him a little bit. So so hopefully that's sorted this little problem out. And then what we can do then, if we do finish, and what we can do now, we do a 3D preview of all the elements. So with DevWing Foam, there's two parts. There's the design side, and then what you've got then is the creating a cutting project to do the actual cutting. So if we now have a look at the wing itself, and you can see how it lines up on the, we just take the image off for the time being. And I think we might take them grids off as well. Just take them extra grids off. Yeah, that looks better. So what you can do is you can see we've got these different elements. You can then sort of unpick the wing. So upper surface there. And then if we do lower surface, we can see all the elements of the wing. So lightning holes. You know, it is a very impressive program, and you know, and when you consider the price of some ARTF models you can buy, you know, especially some of these big EDF foams, I mean, they look fantastic and they fly great. And there's a few guys at our flying club that have got them, and you know, they look awesome and sound awesome, but there's a lot of money invested in them, and you know, and I've seen one or two of them, you know, crash, you know, beyond repair. So it's you know, for me anyway, this program is worth every penny. You know, so hopefully, you know, looking at this, you can get some idea why I like it so much. So once you've gone into doing your design, what you do then is you're going to create a cutting project. So, and that's this option here. And the other thing you've got as well, you can actually draw and print the parts, and you can actually cut the rib sections with a CNC router if you've got one. So you can go into that option there. And then it's asking you what you want. So so we'll just say, we'll just have the ribs. To be honest, guys, I haven't used this part of it very much. So, you know, let's go on to the next section, see what we've got. And it's asking us for the size of our CNC router. Then we need a tool. So not only are you getting a foam cutter, you're getting a milling machine with it as well. So do next. Create and update cutting sheet preview. And then I think what happens then, it takes you into the DevCad part here with all the cutting part. To be honest guys, I haven't used this side at all. It's something I intend to do have a look at, but it's like everything else, it's having the time. So if we go back to projects and our intruder, now if we go in, so you can do the draw and print as well. And there's various options you've got there. Take these nose checking templates off. And if you go into that, and there's various options you can put in there. And then these here, we should have a, so we've got a wing plan as well. It's joined them together because I've told it in that option, but that's probably not the correct way to do it. And then what we've got here on these drawings, so that's the actual cutting project. And these are the drawings. And then what you can do then, you can export them to DXF. And quite often what I've done with this, I've exported them to DXF and then brought them into Fusion 360. And then from the from some of the exports you get from DevFus Foam, I've then put the model together in Fusion 360 as a 3D model to see how it all fits together. And it has sorted a few issues out sometimes. So once you're ready to actually make your foam part, so what you would do then was you select A6 intruder, and then we create a foam cutting project. So we go into foam cutting project. And this is where you can add your wings. So I think what we'll do, we'll just do the outer section. So that's B, so you can see the B on there. And we'll add a left block. Yeah, that'll do. We'll add a left block. We'll just do one. And so this is our wing, how it's going to be cut. And there's loads of options in here, guys. That you can set the cutting strategy for the block. So there's loads of options here. And again, I've covered a lot of this in the full tutorial on this, because there's so many options here that this video will be about 3 hours long. And one of the options that is very good, one that I use, I just will show you on there. If we come right down to the bottom here, rotation of the block along the Z axis, plan form rotation. And that's one I use quite a lot. That really helps. If you're doing a swept back wing and you haven't got enough travel on your foam cutter, you can use that option. And then what it does, it lines the trailing edge up with the wire, which makes the travel a lot less. And then you can, what you have to do afterwards, then you have to cut the root tip to correct angles, which I've shown in one of my videos. And you can get a really swept back wing with that. And also it saves a hell of a lot of foam as well. You don't get much foam wastage, so I use that option quite a lot. And then we've got smart kerf values as well. So what it will do as well, if you've got like your mean kerf value, so if I put 1mm in, which I normally use, the hot wire is 0.4. And if I just say OK to that, what it will do is, if you have a look over here on these surfaces, you can see we've got slightly different kerf values on the root. So on the tip we need a bigger kerf value, because what's going to happen is, because it's not moving as fast, it's going to be over the foam longer and it's going to melt away more foam. So you'd want a bigger value there. So you're going to end up with hopefully the same size of wing. And so that's a really good option. And you've also got, we can set the cutting strategy for the selected internal elements. So we go on to that, and we can select all these options as well. So what you might find is when it's cutting one of these, as you can see here, the wire would come in from the top. Perhaps if you didn't want that, you can go into that. Let's do the hole. That's it. I think it's ventral, I think. Yeah. So you can see what's happened there. It's moved the line down to there. So as the wires come along, it will go in from the bottom. So there's so many options there. So if we go on to, and then we can set the size of our foam cutting block as well. So it's telling us we're going to need a block of 51. You can go in there and you can also say to, well, okay, I've got a block that's 60 millimeters, and it will work out all the settings for you. Obviously we've got quite a bit above and below this, so we could get away with a smaller. So now you can see it's lined up the trailing edge, and then all we have to do at the end of it is cut these root and tip to the correct angle, and it does save you a lot of foam and a lot of travel on the foam cutter. So if you were thinking of producing a real swept-back wing, you think, oh, I haven't got enough travel on a foam cutter, this will do it for you. So what we can do then is apply and test the path limits, and if there's any problem, you'll see what will happen. If there's a problem, you'll see these red lines go above the size. So we can set the size of our foam cutter in there, and then it will check, and then we've got a cutting simulation here. So it probably looks familiar from the other part. This is actually the same simulation that that DevCad give away for free, so we can see what's going to happen. So if we go into the simulation, I'll speed it up a bit because there's a lot to cut on this. Let's turn it round. So you can see that's there's a lot of cutting involved, and it works really well. So that's the simulation. Now this part here is if you want to actually pre-cut the block that you're going to use for that. So you can do that. I don't tend to do it. I tend to do it more on fuselages than wings. It's just as easy just to know what size the block is and cut the block. And then we go on to the next. And it says this because, as you can see, these paths are not lined up. But what can happen then? Do you want to correct it? And just say no. And then we can now tell it what we want to do. Now if you've got their CNC Foam, their firmware and software, if you create this, it launches it automatically. Or what we normally do for the GRBL Mega 5X one, we just says create Gcode for both carriages, and then this is where you can change your access letters if they're wrong. So if you want to use a different type of foam cutter, you can put them accesses in there, and then generally I'll leave most of it the same. You can put a header in there if you want as well, but it puts quite a lot of good comments in there anyway. So all we have to do then, we just say OK, and then I'll just save it in the downloads folder for now, and just call it A6. So Windows threw a bit of wobbly then, guys. I think I might have had too much running, and it's only quite a low powered laptop, this one. So I had to restart it and made a cup of tea while I was at it. So what we got to then was going to have a look at the Gcode. So I'll just switch it back over. We'll have a look at the so here it is, A6 NC. So this is a Gcode that we've just exported from DevWing Foam. So what we'll do, we'll run it through the controller, just see if it's okay there. We've already seen it in the simulator, so we don't need to show it in there. So what we'll do, we'll bring it, I've got it plugged in, connect. So we're connected up there. So we'll load in the Gcode. We'll put it in wing wire, didn't we? And so there's a Gcode. Now you might think that looks a bit strange and weird at the other end, but it's because of all these paths that we've got on the foam cutter. So we'll go into check mode, and if we just run through it, hopefully it should run through without any problems. I might try in a later release, see if I can get it to get the wire to follow it round. It does it when you're cutting it for real, but not in this check mode, so I might have a look at that in a later release. So that's looking absolutely fine there. So we run it through the simulator, we run it through the controller, and everything works. So I didn't expect it not to work. If I've had any problems with DevWing Foam, it's been down to me, not the software. The software just works flawlessly all the time. So so we'll come out of that. We'll just go back onto the website, go right down to the bottom, and if we have a look at all the options, and I think there's only one no in DevWing Foam. Well, there's a few no's. It's not free, and I think you can see why, guys, because of the, it is a comprehensive program, and I think, to get that for free would be expecting a lot, I think. It'll only run on Windows. That's the only probably downside, really. So you can't run it on Mac or Linux, but if you have a look at all the options there, it can do it. So DXX import, it will do that for the wing plan, not the actual wing profiles. Wing plan from image, yes. Curve, washout, dihedral, spars, aileron, thickness, lightning holes, rotate, G93, cutting simulation. There's probably a load more that I haven't even included in it that will do as well. So yeah, so that's DevWing Foam 2. Now, probably if you're just starting out, it might look a little daunting to you. So probably try out one of the free ones first, just to get your head around it and know what you're doing. And then once you come into DevWing Foam 2, a lot of it will make a lot more sense. And as I said, guys, I'm still finding things in it that I didn't realise was there. So it's and sometimes you think, well, I wonder if I can do this, and you go into it and you find there's usually a way to do it. So I highly recommend it. And again, as I said, I'm not being sponsored by them. It's just, it is the best program out there. I'm not knocking any of the free ones, but they're really good, and they might be all you need. So what we'll do now, we'll just go on and have a little look at DevFus Foam. Now, DevFus Foam, I think of it as the companion program to DevWing Foam, and you might have seen some of my videos on the channel where I've done my Hurricane, and I'll put some pictures up of my Hurricane and my T45 Goshawk, and they were all made with DevFus Foam, the fuselages, and the wings were done with, I think the wings are, when I did them, I did the wings with Profili Pro, which was the previous version of DevWing Foam 2. So we'll just open it up and have a little look at it. And if you're into doing scale models or something you can't buy, I mean, that's one of the reasons to build your own models as well, is that there might be something out you want and nobody does it out there, or if they do it, it's the cost is just prohibitive. So that's one of the reasons for doing this. One of the things you can do with all the DevCad software, you can export the projects and send them to friends. I've had a few guys that have had problems, and if you have a look at this one here called Astrohog, that was one that a guy sent me, was having some issues with, and I had a look at that. And there's another one down here as well, Vampire, from Chris Bailey. He was having some problems with that. So you can just go into, and all it does, it just stores them in a projects folder. So if I go into Documents, DevFus Foam, we've got project folders there, and they're all their projects. So all you have to do is, whatever one it is, just zip it up and send it. But there is an export option, export selected project file. So, and then when somebody sends you that, you can import a project file. So you can exchange models like that way, which makes things a bit easier for you. So if we have a look at we're going to look at my Goshawk. We'll Have I done a new version? I think I've got various versions here because I keep trying different things. So this is the T45 Goshawk. I seem to have a bit of affinity with these planes. I originally had a BAE Hawk, a nitro powered one, which I had for years, and it flew brilliant. So I've sort of got a bit of a love for them. So I built and I'll put some pictures up and link it to I did a full video series on it. The only problem was it didn't fly very well. But I am intending to redo it this year, bigger and better, hopefully. So if we go in and have a look. So initially what you have to do, and again I'm just going to go through this briefly, because if we go into it too much, again it'll be this video is probably pretty long as it is anyway, but I do try and keep it as short as I can, but sometimes you just can't. If you do it too short, you just brush over things. So I'd sooner make sure you guys get a better understanding of things. So what we're doing here first of all is put our sizes in. And what I normally do with this is get a drawing from somewhere. And for the Goshawk, so I found a drawing online, and then what I did is I then put that into a CAD package. But you don't have to do that. You can do it all with DevWing Foam to get the sizes out. So I used Fusion 360, imported the model as a canvas, and then scaled it and got some sizes out. So these are the and what I've done is cropped out various parts of the drawing. I'm not sure why it does one bigger than the other, but it works out okay as you go. Then as you go further into it, you can then, no, it isn't initially like this. It does like a best approximation, and then what you can do is you can go in and you can start moving these around to better suit. And so I think these things are splines, which if you've done anything with any sort of CAD program, and what you can do, you can add more nodes, you can delete nodes, you can measure. So basically what you do with that is get it a good outline of your fuselage. And there are some sample ones that come with DevFus Foam. Just cancel that. Yes, so there are some sample ones that come with DevFus Foam. I mean, I've got loads of in here, but the one that I use quite a lot is this Mirage one. And this was one that comes with DevFus Foam, and it was good to go in and see how things were done in there. So if you go in and look at it, you can see how it's been done in there, and all the node points and everything. And then it goes in. There is another screen before this that asks you about your foam size, but because it's created it already, we haven't seen that screen. And this is just a quick overview of it anyway. So then we'll go through, and this is if we wanted to apply any sheeting on there, and then spars if we wanted to put any spars in. So we've got some spars going in. And then we've got lightning holes. So we can see we've got some lightning holes in there as well. And then what we can do then on this, we can actually add, let me come out of this one and go back into the Goshawk. I think that it is, yeah. And if we go to and what you can do with DevFus Foam now is you can actually put in where you want your wings and your tail plane. And what you can do then, once it's done that, you can then go and set your foam cutter up to cut that out. When I did my Hawker Hurricane on DevFus Foam, because this is DevFus Foam 2, it didn't have that option, so I had to sort of basically line it up by eye as best I could, and cut it out with just a manually with a hot wire, and it worked out all right, and it flew great. And I've got some videos of that on the channel if you want to have a look at it as well. So we can put them in, and then we can do a canopy as well. I've actually got it on this one. But what you can do, you can add a new canopy slot, and it will allow you to cut that canopy out. So I did that on the Goshawk as well. And then let's have a look at this. This sometimes takes a little bit of computing power, so hopefully the computer won't crash, because there's a fair bit to do there. Yeah, it's done it. There we go. So that's what it's created for us. So as you can see on this one, I've decided to do, on this particular trial, I was going to do this piece as one big piece of foam, and then these would all be smaller pieces of foam. And what you can do, you can put the images back on as well. So I've put that first block back on. So you see it can't do the very smallest part, but then you can take, so you can go through and you can go and look at the whole thing. So I think this is absolutely a brilliant program, and I've got more models planned for this as well, time permitting. So what we would do then, if we go to finish. There we go. And again, we can cut parts by a 3-axis milling machine. So that would create all the former sections, and then we can create a report of the selected project. If we just have a look at that, this just opens up a web page for this. So this gives us the sizes of all our blocks and the position, which is quite good. And then what we would do then is we've got 3 jobs there, so we can cut the canopy slot, the wing slot, or the main fuselage blocks. So if we go into the fuselage blocks, and then we've got all these blocks in here. So what you can do is run, so if I select, let's select these back 2 here, because they might be more interesting to look at. So select the back 2, run the cutting wizard on the selecting blocks, so this is what it's going to cut for us, and here we've got our kerf value. So kerf value is a bit high there, hot wire diameter 0.4. And then you've got the option there to apply kerf value for longer and shorter pass. I'll just leave it as it is for the time being. We go on to the next. So this is how it's going to look on the, so we go into our simulation. Now this simulation is a little bit different to the DevWing Foam. Very similar, and you can see, and it actually starts at right the end of it. So if we run it back, let's do that one. There we are. So there's our block. So if we then run it through, get it lined up a bit better, and you can double click on the racing car. So I've got some videos on the channel showing all this working as well. There we go. So that's how we'll cut the blocks for us. And then what you've got to do then is obviously join the blocks up together. So we've got basically the same things, update for test path limits, okay. Yeah. Generally what you find if you're doing fuselage sections, you tend to find you need the foam cutter quite a bit closer together, because the angles are a lot steeper, and if you've got it wide apart, you haven't got the travel. Right, so go on to the next one. This again is for pre-cutting the block, and on fuselages I sometimes do this. Oh yeah, it's in here. It's slightly different on DevWing Foam. It's on the last screen. So what we would do, we would create the code here. And you see again, I haven't done very much on this. We can actually create a DXF file as well. So if we create the, we've got the Gcode strategy, which is G93, which is the preferred option for DevWing Foam. And if we just do that, so okay, I think I'm going to put it in there. Right, so it's giving it a name there. There we go. So open it there. And there's our files there. It might look like they're overlapping there, but remember what we're looking at is the actual wire path. So so we'll put it into check mode, and then we'll just run through it. Now, I don't think I've actually tried this on DevFus Foam yet, so it'll be interesting to see if it works. So let's do a run through. So it looks like it's going okay. Yes, it would be nice to see the path on here, so I might look into doing that. And there we go. Everything's okay there, guys. So, so we've seen it on the simulator. We've seen it in the Mega 5X software. So we could probably assume that's going to work okay for us. So that was a quick look at DevFus Foam, guys. So personally, I think they're real good pieces of software, and for DevFus Foam, I haven't found anything else that can do fuselages. I've had guys contact me saying, can you do this with Jedicut? And yes, you possibly could, but it's a lot of work, and then you have to make sure all the parts line up correctly, and and it's just I think guys have done it, but it's just a lot of work to do it with Jedicut. So what we'll do, guys, we'll just go on to the last section where I'll just go over the different pieces of software. We'll just summarise them and tell you what I think is going to be best for you to use, for different circumstances. Well, I hope that's been interesting for you guys to look at the different pieces of software that we can use now. And as I said at the beginning, when I first started, there wasn't very much around. So, but you have got a bit of choice now, and some of it is some of the free stuff is quite impressive now. I'll just switch you over to the other screen, and we'll just do a quick recap on what we've looked at and what I'd recommend. If somebody said to me, which software would you recommend out of all of these, I'd just say to them, all of them. They're all good and they all do the job. It just depends on what you want to do, really, and how far you want to take it. Now, if you're just starting out, then, and this is all a bit new to you, then I'd suggest you start with one of the free ones first, because although DevWing Foam is a brilliant program, it can be a little bit daunting first thing, until you start to understand some of the concepts and the the wording. So if you're just starting out, the Wing Gcode generator is really easy to use. Wing Wire 4-axis Gcode freeware. This one's really good as well. I know a few guys are using this and they've been really pleased with it. I've only done some simulations. I haven't run any test cuts with it yet, but I will do that at some time. And then Wing Designer, I've done a test cut on that, which you'll have seen in the when we looked at that, and that works really well. And the only thing I say it doesn't account for is probably G93. So if you've got a very swept back wing, or a wing with a big difference between the root and tip, then you could have a few issues there. But the rest of the stuff it does, it's just it's very good. I'm very impressed with it. Jedicut, as you can probably gather from the video, I'm not a big fan of Jedicut anymore. I'm not knocking it, and it does the job, but it's not the easiest thing to use, and it's the one piece of software I get the most questions about. If you want something to do, just do wings, guys, then I would probably recommend and you want a free program, I'll probably recommend either Wing Design or any of the previous ones. That they all work and they all do a good job. And then once you get more experience and you're looking for a lot more options, then DevWing Foam it's the best program out there for doing wings, but it's not free, and you can see why it's not free. And then if you want to go into do fuselages, then DevFus Foam, this Goshawk you can see on, and I'll put a little bit of video up of it as well, flying. Took me quite some time to do it, and it had I think we had a 60mm EDF in it. I basically got some of the design parameters wrong. I had the EDF too far up the front, and it didn't come out as big as I thought. And I think the wing sections, the wing was a little bit on the small side. So it was, although we did get it to fly for about 20 seconds, it didn't survive very long. But it did look nice when it was done. Wanting to do scale models, and you can't find them easily, or they're too expensive, then this is definitely a good way to do them. And here's the Hurricane. This was the Hurricane that I did with DevFus Foam, and this was DevFus Foam, the first version before DevFus Foam 2 came out. And I've got some video of that flying, and that took me a long time to do that. Not through, it was difficult to do, just so I got sidetracked onto other projects. But when I actually got it flying, it flew brilliant. We've got the comparison there. And then right at the bottom, they say, well, which one would I choose? And again, it depends what you want to make. For simple wings, then any of the free ones. And I've said Jedicut isn't easy to understand, so I suggest you try one of the others. But if you want to go into a lot more detail, a lot more options, then the DevCad software is the best, in my opinion. So guys, I hope that's been interesting to you. It's this has been about the 4th recording of this video. I've had some technical issues with sound and one or two other things as well. So it's taken me some time to produce it. Thanks for watching. What I'm looking to do next is a few updates on the Mega 5X controller program. I've noticed, even though I've just released a version to it, there are a couple of little minor issues with it which have been highlighted to me, and that's one of the benefits, guys, of you guys testing these programs. I can't test every single option of it. You guys are using it probably more than what I am. So thanks for watching, guys, and catch you in the next video.